Welcome, my friends! Recall that the three primary trigonometric ratios are sine, cosine, and tangent. Each ratio relates an angle to two sides on a right triangle. Sine of the angle theta is the opposite side divided by the hypotenuse. Cosine of the angle is the adjacent side divided by the hypotenuse, and tangent of the angle is the opposite side divided by the adjacent side. An easy way to remember these ratios is by the familiar saying, SOHCAHTOA. Also recall the Pythagorean theorem, which allows you to solve for a missing side in a right triangle, and tells us that a squared plus b squared is equal to c squared if a and b are the legs of the triangle and c is the hypotenuse. If you are a little shaky on either the Pythagorean theorem or sine, cosine, and tangent, consider watching my videos related to those topics before continuing with this video. Let's look at this triangle. Let's say we are asked to find the three primary trigonometric ratios, sine, cosine, and tangent. We are missing one of the sides, which we will need to know for some of the ratios. Since we have a right triangle, we can solve for the missing side using the Pythagorean theorem. 9 is the hypotenuse, as it is opposite to the right angle, so we can label it as c for use in the Pythagorean theorem. 4 is one of the legs, which we can label as a, and the missing side is the other leg, which we can label as b. Plugging into the formula, we have 4 squared plus b squared is equal to 9 squared. This simplifies to 16 plus b squared is equal to 81. Subtracting 16 from both sides, we have that b squared is equal to 65. Taking the positive square root of both sides, we get that b is equal to the square root of 65. Now that we have found the missing side, we can solve for the three primary trigonometric ratios. Sine of theta is opposite over hypotenuse, which is 4 over 9. Cosine of theta is adjacent over hypotenuse, which is the square root of 65 over 9. Tangent of theta is opposite over adjacent, which is 4 over the square root of 65. Now, technically this is correct, but our answer for tangent is considered to be in an improper form. We typically don't like to leave a square root in the denominator. To fix this problem, we can rationalize the denominator by multiplying by the square root of 65 over the square root of 65. The reason we can do this is because the square root of 65 over itself is just 1, so multiplying by this ratio does not change the value of our answer, only the way that it looks. On the numerator, we will have 4 times the square root of 65, and on the denominator, the square root of 65 times itself leaves us with just 65. This might not look nicer to you, but this is the mathematically correct way to express your answer for tangent in this example. 4 square root 65 divided by 65. Consider this triangle. Instead of sine, cosine, and tangent of theta, we want to find cosecant, secant, and cotangent of theta. Remember that these are the reciprocal trig functions. Sine of theta is opposite over hypotenuse, which means that the corresponding reciprocal function of cosecant must be hypotenuse over opposite. Cosine of theta is adjacent over hypotenuse, which means that the corresponding reciprocal function of secant must be hypotenuse over adjacent. Tangent of theta is opposite over adjacent, which means that the corresponding reciprocal function of cotangent must be adjacent over opposite. Before we find each of these ratios, we notice that we are again missing a side, which we can solve for using the Pythagorean theorem, since we have a right triangle. 6 is one of the legs, which we can label as a, and 5 is the other leg, which we can label as b. Like I've mentioned in other videos, it doesn't matter which leg you label as a and which you label as b in terms of the Pythagorean theorem. All that matters is that you label the hypotenuse as c, which is our unknown value in this example. Plugging into the theorem formula, we have 6 squared plus 5 squared is equal to c squared. This simplifies to 36 plus 25 is equal to c squared. 36 plus 25 is 61, so we have 61 is equal to c squared. Taking the positive square root of both sides, since the negative square root doesn't really make a lot of sense for side lengths, we have that c is equal to the square root of 61. Now we can find our three reciprocal trigonometric ratios. Cosecant is hypotenuse over opposite, which is the square root of 61 divided by 5. Secant is hypotenuse over adjacent, which is the square root of 61 over 6. Cotangent is adjacent over opposite, which is 6 over 5. We don't need to rationalize any of our denominators in this example, as nowhere do we have a square root in the denominator. These are our final answers. Let's try this problem, where we need to solve for the missing side length x. We know one of the angles is 56 degrees, and also know that the side opposite to that angle is 5 units long. We can't use the Pythagorean theorem to find the missing side, as that would require us to know two sides, and we only know one side. Instead, we can use one of the trigonometric ratios to help us solve for x. The trick is to pick a trigonometric ratio that involves the side length that you know, as well as the side length that you don't know that you would like to find. In this example, we know the opposite side, and we would like to find the hypotenuse. What trigonometric ratio relates the opposite side to the hypotenuse? Well, that's sine. Or I guess if you wanted to be tricky, you could have said cosecant, but most people would rather deal with sine if they have the choice. Sine of 56 degrees is equal to the opposite side of 5 divided by the hypotenuse of x. Then this turns into an algebra problem. To solve for x, we must multiply both sides of the equation by x. Then we have x times the sine of 56 is equal to 5. Dividing both sides by the sine of 56, we get that x is equal to 5 over the sine of 56 degrees. If we grab our calculator and type in 5 over the sine of 56, we will get approximately 6.03 if we round to 2 decimal places. The missing side length is equal to 6.03. If we want to, we can continue working with this triangle to quote-unquote solve the triangle. Solving a triangle just means solving for every angle and every side length. At this point, we are missing the base of the triangle as well as one of the angles. The missing angle, which we will call theta, is very easy to find if you know that the sum of all the angles in a triangle must always be 180 degrees. That means you can take 180 and subtract the two known angles to find the missing angle. In our example, if we take 180 and subtract 56 and 90, we will get 34. The missing angle is 34 degrees. As for the missing side on top, you could either use the Pythagorean theorem or a trig function to find its value. Some instructors say that you should avoid using rounded values in future calculations, and since the 6.03 side is already rounded, we might want to avoid using the Pythagorean theorem, which requires us to use this value to avoid compounding the error. I'm going to use tangent, which relates one of our angles of 56 degrees to the opposite side of 5, over the unknown side, which I'll call y. That way I've avoided using the rounded 6.03 number when finding the final missing side. We have tangent of 56 is equal to 5 over y. If we multiply both sides by y, we will have y times tangent of 56 is equal to 5. Dividing both sides by the tangent of 56, we get y is equal to 5 divided by tangent of 56. Typing this into our calculator, we get that y is approximately equal to 3.37 if we round to 2 decimal places. We can place this on our triangle. And there you have it. We have solved this right triangle. Let's try a word problem. Say that a ladder is leaning onto the side of a house at an angle of elevation of 69 degrees. The ladder sits on the ground 12 feet away from the side of the house. Find the length of the ladder. Let's start to draw a picture of what has been described in this problem, which is unsurprisingly going to take the form of a right triangle. We have a house whose side can be thought of as a vertical line. We are not told how tall the house is and are not asked to find this value. There is a ladder leading up against the side of the house, and we do not know how long the ladder is. That's what we're trying to solve for, so I will label this side as x. The distance from the base of the ladder to the side of the house is 12 feet, which is the base of our triangle. We also know that the angle of elevation from the ladder up to the house is 69 degrees. Since the ground is perpendicular to the house, which is built straight up, we have a right angle between the house and the ground. Now that we have the picture drawn, we can solve for the length of the ladder x, which is the hypotenuse of the triangle. we need a trig function that relates the adjacent side to the hypotenuse. Can you think of which function that is? The answer is cosine. Cosine is adjacent over hypotenuse. Or I guess you could have said secant, which is hypotenuse over adjacent, but no one wants to work with the reciprocal trig functions if they don't have to. Cosine of 69 is equal to adjacent over hypotenuse, or 12 over x. If we multiply both sides by x, we will get x times cosine 69 is equal to 12. Dividing both sides by cosine of 69, we get that x is equal to 12 over the cosine of 69. Typing this into our calculator, we get about 33.49 if we round to the nearest thousandth. The length of the ladder is about 33.49 feet. Alright, my friends, that wraps up our video relating to right triangle trigonometry. Join me in the next video where I will discuss how to solve for an unknown angle in a right triangle when you know two sides using inverse trig functions.